The momentum is a useful quantity in collisions because it's conserved, i.e. the total momentum before is equal to the total momentum after, in the absence of any external forces such as friction or components of weight and so on. So we're looking at flat surfaces, no friction involved. So if we look at that, what that looks like in an example, so we've got a trolley here, right, which we collide with another one, and then they stick together and move off. So if we consider the momentum before, then we can work out that the first trolley was moving at 2 meters per second, so it has a momentum of 2 kilogram meters per second. The other trolley wasn't moving, so it has a momentum of 0, and therefore the total momentum, 2 plus 0, is 2 kilogram meters per second. If we look at the momentum after, then they were stuck together and they were moving at 1 meter per second. But because they're stuck together, the total mass is 2 kilograms, multiplied by a speed of 1 meter per second, gives you total momentum of 2 kilogram per second. So we can see, if we compare the momentum before and after the collisions, we get the same for both. So we can show momentum is conserved. And usually that's expressed as the total momentum before a collision equals the total momentum after, in the absence of net external forces. That's because we've ignored friction, okay? So we tend to do these experiments on things like air tracks to minimise friction.